Linear relationships, direct variations, y equals mx. This video was produced by Math GPS. Direct variations are a type of linear relationship where quantities are predictable and proportional. Graphs always form a line. The origin 0, 0 is always a solution. Graphs always have a constant rate of change or slope, identified as m in the equation above. And equations show the constant m being multiplied or divided. Situation 1. Spiders have 8 legs. We can take this information and build a table. Number of spiders will be our x value, number of legs will be our y value. Our slope or rate of change will be 8 because every spider has 8 legs, and we're going to multiply by 8. So if there are 0 spiders, 0 times 8, 0 legs. 1 spider, 1 times 8, 8 legs. 2 spiders, 2 times 8 is 16 legs. Until finally we determine that any x, any number we choose, multiplied by 8, will give us a product that is equal to y, the total number of legs. We can use our table of values to calculate or write an equation for this situation. X times 8 equals y, typically rewritten in standard form, y equals 8x. We can then take the values in the table and rewrite those as points to be graphed on a coordinate grid. When we graph the points, as shown in purple, we see that there seems to be a constant rate of change. The points go up in a very predictable pattern, and it looks like a direct variation, but we won't know until we graph the line y equals 8x. When we graph the line, where we connect the points and continue and eliminate all space, we do see a direct variation. The constant rate of change or slope is equal to 8. The origin is a solution. The graph is a line. And additional points are predictable and proportional. Situation 2. A cold front in Texas caused temperatures to drop 21 degrees in 3 hours. We'll create a table based on this one statement, but we have to calculate a unit rate before we can begin. If we divide 21 degrees by 3, we find that the unit rate or rate of change is a drop of 7 degrees per hour. So our slope is going to be -7, indicating a drop of 7 degrees each hour. We'll use the number of hours, 0, 1, 2, 3, multiply by -7 to calculate the change in degrees y. If we write an equation to represent this table, we'll find that x times -7 equals y. In standard form, y equals -7x. We can rewrite the values in the table as points so that we can graph them on a coordinate grid. The points in purple appear to be descending at a very constant rate of change. They appear to be very straight. They include the origin, but we won't know for sure that it is a direct variation until we connect the points and graph a line. If we graph the line y equals -7x, we see a direct variation. The constant rate of change or slope is equal to -7, the degrees that the temperature drops each hour. The origin is a solution. The graph is a line. Additional points are predictable and proportional. Situation 3. 1 inch is about 2 5/10 centimeters. Using this information, we can create a table of measurements. The number of inches, x, the number of centimeters, y. We'll use the 2 5/10 information as our slope or rate of change. 0 inches times 2.5 equals 0 centimeters. However, 1 inch times 2 5/10 gives us 2 5/10 centimeters. If we take 6 inches and multiply it times 2 5/10, we determine a measurement of 15 centimeters, and so forth. Once we have data entries in our table, we can then rewrite those as points so that they can be graphed on a coordinate grid. We can also determine an equation for this information. X times 2 5/10 equals Y. More commonly written in standard form, Y is equal to the value of 2 5/10 multiplied times X. We'll graph the points so that we can see a relationship. The points appear to be straight. The origin is included. I believe this will be a direct variation when we connect and graph the line. If we graph Y equals 2 5/10 X as a line, we do see a direct variation. The constant rate of change or slope is equal to 2 5/10. The origin is a solution, the graph is a line, and additional points are predictable and proportional. This video was created by Math GPS. You may download a free file at our website. Have an amazing day.